Hello and welcome to the Math Bender. I'm Adnan Zedi, and this is the last session on permutations and combinations. Before starting off, I want you to know that this is the last session on A level S1 permutations and combination. The questions related to additional mathematics are already done. The topic related questions were all finished. This is purely for S1 students who require a little bit of extension of permutation combination in terms of many other permutations happening at the same time. So this is not for additional mathematics O level students. Let's start. So in a group of 25 students, there are 6 swimmers, 8 cyclists, 11 runners. Each person competes only in one of these sports. So 7 people to be selected from those 25 people. Find the number of different ways in which 7 can be selected if only exactly one swimmer. So we need to make our data. So one swimmer, at least 4 cyclists. Now this is and at least mean it can be more than that. And at most mean that it has to be maximum of 2. It can be less than that. So we need a pool of 7 people. So one swimmer, let's keep 4 cyclists. 4 cyclists has to be there at least. So 4 and 1, 5, and 2 runners. It can also be one swimmer, 5 cyclists, and 1 runner, or one, or it can be one swimmer, 6 cyclists, or 0 runner. At most 2 runner means that maximum it can be 2, it can be 0 as well, minimum. So there's no count for minimums. So when we write down their respective, so we will see that this is going to be 6C, 1 out of 6. We are choosing one swimmer, times with 8 cyclists are in the pool, times choose 4, and 11C2 plus 6C1, 8C5, and after getting all the answers we can just add them up. So for another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. The team members stand in a line for a photograph. Now in this situation, these people are already selected: 2 swimmers, 3 cyclists, and 4 runners, and they have to stand in a line for photograph. So how many different arrangements are there for 9 people if swimmers stand together? So now this is where the arrangement matters. So swimmers, cyclists, let's first note down all the things, and runners. So it says that the swimmers stand together, the cyclists stand together, and the runners also stand together. So the best way is make a box around it, enclose them. They can shuffle within these boxes only. So 2 factorial times 3 factorial times 4 factorial times. Now these are 3, 1s, 1c, and 1r. So which means that this is going to be 3 factorial. So times with 3 factorial eventually. So the reason being that since I've enclosed 2 swimmers in one box, making it a big swimmer compartment, 3 cyclists in one box, making it a cyclist compartment, and 4 runners in one box, making it a runner compartment. How many different arrangements are there if 9 people, if none of the cyclists stand next to each other? Now this is what I want you to look at. I'll solve this. None of the cyclists stand next to each other. So there are 3 cyclists, 2 swimmers, and 4 runners. So if we have to separate these, so what we do is let's fix these people, swimmers, runners, and there are 2 cyclists. I've already fixated them. So the cyclists can only come in these places. There are 3 cyclists. They can come separately here. That's how they will be separated. So out of 1, 2, 3, 4, 5, 6, 7 places, we can choose 3 cyclists. So 7C3 times 3 factorial, because those cyclists can also shuffle, times rest of all the people, cyclists and rest swimmers and runners, they can shuffle within themselves. So this is 1, 2, 3, 4, 5, 6 times with 6 factorial. They are shuffling within themselves as well. Okay, so find the number of arrangements of the letter in the word Casablanca in which 2 C's are not together. So first step is that we need to see how many repetitions. So C is repeated 2 times, A is repeated 4 times, and there are 10 letters in all. So in which 2 C's are not together. Okay, so if you look at this one, this is pretty much more or less the same question we did here, where the cyclists were not supposed to stand next to each other. Since there were 3 cyclists, I had to separately take them and blank them. But since there are 2 C's and they should not be together, the best way to approach it, although you can take this approach as well, both are possible, but the best way I would rather say, when there are 2 options only. So when you cater to this, what you could do is total possibilities minus possibilities with C's together. From the total possibilities, if I subtract all the possibilities where C's are together, it will give me all the possibilities where C's are not together. So what I'll do is, total possibility of this is 10 factorial over 2 factorial times 4 factorial, because 10 factorial all the letters shuffling, and since A is repeated 4 times and C is repeated 2 times, minus, if I keep all the C's together, so this will give me 2 factorial for C, making a C in the box, times with 9 factorial over 2 factorial. This will cancel later on because C is repeated, times with 4 factorial. Now if you subtract this, it will give you the answer this will give you 60480. Now CASABLANCA is asking for the arrangement which has A at a beginning and A at the end. So let me write that, and A at the end, and exactly 3 letters between the two C's. So let me write C's first here. So I can say that the C can be written here, 1, 2, 3, and C, or A here, C comes, and as you can see that since I'm taking C's one step ahead, so C can further move to this position and then this position. So there are 4 possible ways, 1, 2, and there are 2 more as well. Now for letters to be shuffling within there, A's are fixed here, we don't need to cater to them. Now then we have C's fixated here, we don't need to shuffle them either. But C, A, S, A, B, L, one more A, N. So I've written down all the possible ways. So now these are the blanks, 1, 2, 3, 4, 5, 6, shuffling. Rest are all fixed. And out of those shuffling, the ones that are shuffling, so if I write that down as 1, 2, 3, 4, 5, 6, so 6 factorial over, out of them, there are 2 A's which are repeating as well, over 2 factorial. And since this is repeated 4 times, times with 4. Okay, so moving on to another one. So out of these 10 letters, 5 are selected. Find the number of different selections in which 5 letters include at least, again, at least means it can be more than 2 A's, and at most 1 C, maximum 1 C. So let's keep first 2 A's, 1 C, and 2 other letters, any other, or 3 A's, 0 C's, because at most 1 C, so which means none, and then 2 other letters. So from that 10 letters, if I remove 4 A's, which makes it 6, and then 2 C's, which makes it 4. Then 4 A's and one other letter. Now that is not now this is not enough. It can also be 2A, 0C and 3 other letters, or 3 A's, 1 C and one other letter, or 4 A and 1 C and no other letter. So if I write them down, I'll see that this is going to be 2 A's are selected already. There is no C's that will apply. 1 C is also selected. 2 other letters are going to be in the selection pool. So when I remove 2 C's and 4 A's, so 6 letters gone, there will be 4 letters left. So 4C2 is the selection criteria. 3 C's, this will be 4C2 again, plus this will be 4C1, this will be 4C3, plus this will be 4C1 plus one possible way. So if we add all of these values, we will see that the final answer is equals to 25. Okay, so looking at this one, now first step, you need to take down all the possible repeated letters. So repetition of D is 2 times, E is 1, 2 and 3. So E is 3 times, and let's call all the other letters L. So since there are 9 letters and 3 and 2 5, so there are 4 letters, other letters. The condition is that the 3 E's are together and 2 D's are not. So 3 E's have to be together. So what we can do is, so since we have total 2 D's cannot be together. So one way to look at it is 1, 2, 3, 4 and 5. And I'll, with a different color, I'll mark the possible positions of D could be. The green markers that I just written down are for D's. So D could be here, 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 and in these, any two of these 1, 2, 3, 4, 5, 6 places. And I've taken E as one blank because they have to be together. So I'll keep that E as capital E. So E, capital. Rest are 4 letters. So let's call it L, I, V, E, R, E, D. Okay, so this is the condition now. So as I could see that out of those 6 places, 6 C2, I've chosen 2 slots, different slots for these, times with E all block. So these can shuffle within themselves. So 1, 2, 3, 4, 5 times 5 factorial. Since I've taken the whole e as 1, so I don't need that to take over 3 factorial, because I've taken triple E as a 1 capital E. So all the 3 E's will be moving together anyway in those slots, and these will not be together. So 6C 2 times 5 factorial. So 5 letters are to be selected. Now out of these 5 letters are to be selected. Number of selections if 5 letters includes at least 1 D and 1 E. So there are what, 2 D's, E's are 3, and the rest of the letters are 4. So at least 1 D and 1 E. So let's keep 1 D, 1 E, and we are to select 5 letters, so 3 other letters. It can also be 2D, 1 E, and 2 letters. It can also be 1D, 2E, and 2 letters, and 1D, 3E, and 1 letter, 2 D's, 3 E's. That is it. So for 1D and 1E is selected, I'll rest of the 4 letters, so we will write 4C3 plus 4C2 plus 4C2 plus 4C1 plus 1. Remember that this is 2 D's and 3 E's. All of them are there. So this is only one combination. So if you add all of these, it'll give you the answer. So a group of 3 boys, 4 girls, and 5 adults. In how many ways can be chosen if exactly one adult is included? So we are to choose 5 people. So only one adult is needed. So we write 5C1 times. Now there is no restriction on boys or girls. There is only restriction on one adult. So that's why I've taken out of 5, I've chosen one adult. Rest, I can keep them in a pool. I'll write 7C. Remaining of the people to be chosen are 4. In this way, it can be any possible ways. But since our restriction was one adult, so that's why I took out 5 adults separately and chose one from it. So in this question, out of a team of 5 peoples to be chosen, and it should include at least 2 boys and at least 1 girl. So a minimum of 2 boys have to be there and a minimum of 1 girl. So what we could do is 2 boys, 1 girl, and then 2 adults, or 2 boys, 2 girls, and 1 adult, or it could be 2 boys, 3 girls. We can also look at 3 boys, 1 girl, one adult, three boys, two girls. These are the only possible ways which fulfill the condition that is required in part B. So if we are to select two boys, so 3C2 times with 4C1 times with 5C2 plus 3C2 times 4C2 times 5C1 plus 3C2 times with 4C3 plus 3C3 times 4C1 times 5C1 plus 3C3 times let's look at another one. The same group of students stand in a line, so 12 students in which we have 3 boys, 4 girls, and 5 adults. And the arrangement should be in such a manner that the adult has to be at each end. So the first one is adult and the last one is an adult. And 3 boys stand together. So let's keep these 3 boys here and make a box out of it. Rest of these 4 girls and 3 adults. So now notice that this this whole bunch of boys can shuffle within these slots, like the case where we talked about all men together. So it will be for this one, there are 5 possible ways times with, there are 4 possible ways an adult could there be times with 3 factorial for all the boys shuffling within themselves, and then 1, 2, 3, 4, 5, 6, 7, and 8 times with 8 factorial. The final answer will be 5 times 4 times 3 factorial times 8 factorial. That's going to be a big number though, 4838400. Okay, so a social club member, there are 15 members, 8 are men and 7 are women. And the committee has to be consist of 5 members. So, and it should be in such a manner that there should be more men than women. So, one way could be 3 men, 2 women, or 4 men, 1 woman, or 5 men, zero women. When it says more men than women, but it did not specifically mention that women has to be in the committee as well. So that this condition in itself is fulfills the question condition. So what we'll do is 8C3 times 7C2 plus 8C4 times 7C1 plus 8C5. So the 15 members are having a photograph taken and they stand in three rows with three people in the front row. So let's take three people on the front row, five people in the middle one, and seven in the back row. So in how many different ways 15 members can be divided into a group, and there's no restriction here. So we write 15C3 when three people came here already. So the first row, second row, and third row. 15C3 times. Now three people are already in the first row, which leaves 12 people, 12C5 in the second, and after 5 people are also selected, we will be left with 7C7. So in one photograph, there are these people in the last row, and they're supposed to be arranged in a manner where Abel and Betty are supposed to be next to each other, and Free and Gino are supposed to be not next to each other. So A and B together, and F and G not together. So let's see how we can work this out. So there are a total of 7 people. So what I'll do is I'll keep A and B separate. Then there's another third friend of theirs, fourth friend of theirs, and fifth. And F and G can only fit in these red spots. That is the only these are the only places where they can fit in order to fulfill the condition of the question. So there are total 5 possible spaces, and out of which they are to take any 2. So 5C2 times 2 factorial, because F and G can shuffle as well. Not necessarily F has to be on the first one and G has to be on the second. It could be either way. Now times with, they can shuffle separately within those slots. 4 factorial times with A and B as well can shuffle 2 factorial. It gives you a total answer of 960 possible ways. So that is it. I'll see you in my next video. Until then, take care. Bye.